Hello, Namaste. Welcome to this channel, Dr.ARM's Chemistry. Friends, we were discussing stereochemistry, in which we have seen various other types of isomerism, that is cis-trans, structural isomerism, etc. And in this case, we are going to see today the enantiomers. We are going to see this enantiomers. So first of all, we will see what is meant by enantiomers. So enantiomers are the two species which are having same molecular formula. Structural formula is also same, but the arrangement of the ligands around the central metal ion is such a way so that they are viewed as non-superimposable mirror images. Means the two structures are same, but they are appearing like their mirror images. And therefore, such phenomenon is called chirality. Means this phenomenon, such phenomenon occurs due to chirality. This phenomenon occurs due to chirality. Chirality means the ligands or species which are containing asymmetric center. Asymmetric center. For example, say this is carbon, and we are having, say, this A, B, D and E. So here the carbon is bonded to every different, with 4 different atoms or groups. In this case, we consider these groups as ligands which are attached to the central metal atom or ion. So chirality is important factor here because it gives the existence to different species. So enantiomers are coordinated when the chelating ligands are involved. Means the ligands are of chelates which are having heteroatoms, and because of which they give the different points of attachments. Now here important thing is that the term means we have seen earlier in the previous lecture distereoisomers. So they are related to the arrangement of ligands or atoms which are giving only the geometrical isomerism, that is cis and trans isomerism, and the isomers are called geometrical isomers or distereoisomers. But these distereoisomers do not exhibit such type of, means they are not enantiomers. Now if we see, means when we measure the difference between the isomers which are called enantiomers, these isomers are called optical isomers, and they show the change in their optical activity. Means they have certain difference in their optical activity. So this optical activity is measured by, so we will see that later on, but in short here we will see that the optical activity is different of such isomers because they, means each isomer shows or causes change in the plane of or rotation of the plane of plane polarized light. Means every isomer causes rotation of plane polarized light either in clockwise direction or in anti-clockwise direction. And on that basis we are measuring the difference between such isomers. So these isomers are shown to have the specific angle of rotation, that is called alpha d, and it is, when it is plus 12 degrees, it is called plus or dextro rotation. When this alpha specific angle of rotation is minus 12 degree, it is called minus or zero rotatory. This is dextro, this is zero rotatory substance. Now on that basis we will see what are the different types of optical isomers. So one is D, and these isomers, optical isomers, are preferentially differentiated with, or they are shown with D, symbol D, and L. So these are the prefixes. These are the prefixes. So these D and L isomers, these D and L varieties are also indicated by plus and minus sign. Plus and minus sign. So here this plus indicates the rotation of plane polarized light in clockwise direction. In clockwise direction, whereas this negative sign or L indicates that is such type of species show rotation of plane polarized light in anti-clockwise direction, or in other words we can see this rotation is taking place in right direction, and this is anti-clockwise means towards left. Means these are conventions which are normally used in order to distinguish between the D and L isomers. Now these isomers are also distinguished in different ways. They are also represented in using another terms, that is R and S prefixes. R and S prefixes. So these are also conventions which are indicating the leveling of chiral carbon atom, means asymmetric carbon atom, which has tetrahedral geometry with 4 different groups attached. That is chiral. It has chiral center, means metal ion is bonded to 4 different ligands. Or the ligand may be same, but the points of attachment means the coordinating atoms are different. So whatever may be the case, the ligands are attached to the center, giving such a asymmetric structure. So the center becomes chiral. In this case, so such type of notations are called in gold, relog notations. In gold, prelog notations. So the 4 groups which are attached to the central metal ion or atom are prioritized, means when we are viewing the 4 different atoms or groups or ligands, we are giving some priority on the basis of their atomic number. The atom with highest atomic number, they has highest priority. And the priority in that case, the CX axis here, X is the atom with lowest atomic number or priority. So the structure is viewed down the CX axis, and on that basis we are giving these terms R and S. So CX vector is used as the level from which the priority is considered to be increasing. Priority is considered to be increasing from this CX axis, or the atom with highest priority, or the atom with the lowest priority. Now we will see the example. Here R is representing rectus or clockwise, and S represents sinister or anti-clockwise. Now we will see the example. Say this is carbon. It is attached to this marine. So this is hydrogen. This is Br. And this is Cl. Another structure is like this. Carbon, this iodine, hydrogen, Cl, Br. Now, if we see this carbon hydrogen axis is considered as the starting point. So, the priority is given like this. So, this iodine has highest priority. So, this is labeled as 1. Next to this is bromine, which second priority, and chlorine has third priority. So, if we move in this way, in this direction, so it shows that the first to second, second to third. So this is clockwise in direction or rectus, and therefore it is labeled as R. In this case, we are having the same priority 1. Bromine has second, chlorine has third priority, and the order is like this 1, 2. So we are moving in this direction, that is anti-clockwise direction, and therefore this is has sinister or S structure or S isomer. So this is R isomer because the priority order we have to remember: highest atomic number, next to this is bromine, next is chlorine, and this is lowest. Then, so these are tetrahedral structures. Okay. So here the priority order shows in clockwise direction. Priority shows that the moving is when we are moving from highest priority to lowest, and the direction becomes R, rectus or clockwise. In this case, the priority is 1, iodine, bromine, Cl in this direction. So the clockwise, anti-clockwise direction is shown here. So it has sinister isomer or sinister structure. So this notation is used for chiral origin ligands and also for tetrahedral complex. We have seen that these are tetrahedral structures. So this is about R and S, delta and lambda, delta and lambda prefixes, delta and lambda prefixes. So these are also enantiomers are in octahedral structure. So they are in octahedral complexes. Octahedral complexes, which are containing at least 3 ligands of same nature, means 3 equivalent ligands. So the important requirement is that there should be at least 3 identical ligands. So this is important requirement, means there are in octahedral complex, you know that there are 6 ligands. Out of 6, at least 3 ligands should be identical. And these are chelates or trischelates. So they are distinguished using the terms delta and lambda. So these are This is delta and this is lambda. So these prefixes are used in this way. So octahedral, this ligand is viewed. So first of all we will see the structure, and then so that it will be easy to understand. Now if we see the structure, so say these three structures, this is we have drawn only the view shape of the molecule, so that it becomes easy to understand. Like this. Like this. Now, these three ligands, 1, 2, 3, are identical. These may be different or same. Now, when the octahedral ligands are having, these three ligands are having threefold axis. So we can imagine the three axes which are pointing towards us. Means the molecule is viewed in this. This is octahedral. This is octahedral structure. But we are viewing this molecular structure in this direction. So this has say 1, 2, 3, then 4, 5, 6. 6 coordinate points of attachments, and center is the metal. Now, if we see that this is bonded in this, means front, this is front point of attachment, it is bonded to the point showing these three, which are shown in different fashion, are on back side. These three are blue colored ligands are towards us, and this black color indicates the three ligands are at backward position. Now, so while we are connecting the ligands in this, so the shape, or we are showing the attachments in this. So this attachment is pointing in this direction. So for our understanding, we are showing in this way. So this shows that means these arrowheads are not required. This is for our convenience only. So because this ligand is attached, it chelates. The attachment is like this. So when we are showing this attachment, it is in the forward direction or clockwise direction. So it is called delta. In another way, the same structure can be shown in this way. The same structure can be shown in this way. So we are showing this outer structure. and this attachment is like this. So this is also same. Means both structures are identical. There is no difference. So they are shown as delta isomers. Now, let's see, in both cases we show that the arrowhead is also in this way, but there is no need to show this arrowhead. So that is shown for our understanding. And this is also same. Means we have represented the two structures in different way, but both are delta. Now we will see lambda type of structures. Here we will show that so here you will find that we are moving in this direction. We are moving in this direction. So like this. Or in another structure, so you will find these two structures are also identical and they are called lambda structures. So here you will find that the connection is in reverse direction or anti-clockwise direction here in this case. So it is called lambda. So such type of structure is viewed so that three identical ligands are towards us and three other ligands are to opposite side or other side, and the linkage is in this way. In this case clockwise, in this case anti-clockwise. So or in other words, we can say right-handedness means here you are finding that the linkage is right-handedness and here it is left-handedness, and therefore the name is shown in this way. So these are showing the handed right or left-handed ligands. Now the third structure is third type like this, that is delta and lambda prefixes. So we are using these prefixes in order to distinguish the optical isomers. In case of the complexes which are chelates and the chelating ligands are more complicated, then we are using such type of denomination, or we can say representation of symbols. Now if we consider the example of 1,2-diaminoethane, for example if we consider 1,2 diaminoethane. 1,2-diaminoethane. So these ligands are attached to the metal center and they form 5-membered ring structures. So these rings are not planar, but they are having envelope conformation. So they give envelope conformation. Envelope type of conformation. So this is most easily seen using the Newman's projection formula, and the structure is viewed in the direction of carbon-carbon bond. So here we will find that there are 2 carbon atoms, and that are to be said, this is one carbon atom, this is another carbon atom. So we have to view this in this direction. So both carbons should come in the same direction. Then only we can view it accurately. So the 2 enantiomers are possible and distinguishable by using such type of symbols. So here we will see the structure of 1,2-diaminoethane, which is attached to the metal center. So we can show this as, so say this is hydrogen, another hydrogen, third hydrogen. Here it is nitrogen, NH2. Now, so these are the ligands which are having, which are show the other ligands like this, which are pointing in backward direction. Pointing in backward direction. Say these are this is hydrogen, this is another hydrogen, and this is NH2. So now you can imagine that these 2 hydrogens and this NH2 is pointing towards us, and this is pointing behind, and there are 2 carbons of this ethane. This is one, and that second carbon is viewed in this form of spherical, so that it can be visible to us. Means we are trying to visualize in this. This is called lambda, or we can say this is lambda. Now this is mirror, and we can imagine the structure like this. This is NH2. So these are the 3 hydrogens, and this is nitrogen in pointing towards us. this structure and this structure, these are mirror images of each other, and they are so one is called lambda, another is called delta. So the prefixes are used in this way when the two carbons are viewed in this way, so that one is visible easily, but that backward is not visible, but that is indicated in this form. So using this mirror image structure, we can understand that how these lambda and delta are used as a prefix. Prefixes or descriptors, we say the descriptors P and M are used. Descriptors. So here P indicates plus and M indicates minus. Plus and minus. In this, for this purpose, the structure of the complex is helical, and it is or propeller or screw shaped structure. The structure of the complex is helical or propeller or screw shaped. For example, SN has a helical chain structure, and it can have right or left-handed isomer, which is indicated as plus. So the right-handed helical structure is called plus, and the left-handed helical structure is called minus. So we can see the example so that it will be easily understood. So in this structure we have to begin this structure from here. So this is plus or right-handedness. So this is right-handedness, and therefore it is called a P symbol, prefix P. Hexa, P hexa, helicene. Hexa, helicene. And another structure So this thickened diagram here is shown for our representation, that is, it is pointing towards us and it is spirally moving down. Similarly, it is also spirally or helically moving down. So this is last shown in blue color or lower structure. So it is screw-like structure, and here you will find that the dotted line indicates that they are lying at lower position or to the other end of the helix, and these black hydrogens, are pointing towards us. So such type of arrangement in which the structure is moving down a left-handed direction or anti-clockwise direction. So it is called M, that is minus M hexa helicene. M means minus hexahelicene. So in this way, we can distinguish between how to use the prefixes M and L, or lambda and delta, etc., R and S, etc. So we have seen these various types of prefixes or symbols which are conventionally used here. So with this we will stop our discussion. Please subscribe to this channel and hope that you will press like button and bell icon. Thank you very much for watching this video.